Okay guys, we're going to go over the nephron model. When we talk about the nephron model, this is a blown up section of the renal cortex here. And then these are going to be the division line from the renal medulla. So again, the renal cortex and the renal medulla. If we were looking at the kidney model, the division line would be the arcuate artery and the arcuate vein, which divides the renal cortex from the renal medulla. We're going to go through blood flow first, and I'm going to show you the differences between the blood flow through the cortex and then the blood flow through the renal medulla. Okay, as we mentioned before, blood enters the kidney and then eventually it reaches the arcuate artery. It goes, then it ascends to the interlobular artery, and now we're going to learn that there is an afferent arteriole, which means to arrive, and it goes to a structure which is called the renal corpuscle, which has the glomerulus, which is going to filter out blood. But any blood that exits this renal corpuscle is going to come out through the efferent arteriole, which means to exit, and it goes into a capillary bed of the cortex, which is called peritubular capillaries because they are wrapped around the renal tubes, so peritubular capillaries. It drains then into the interlobular vein and then out the arcuate vein. Now, the renal medulla is a little bit different. You have blood entering through the arcuate artery, the interlobular artery, to the afferent arteriole, to the renal corpuscle. Any fluid that exits goes out the efferent arteriole, and it goes down this straight arteriole, which goes to a capillary bed called vasa recta, which means it's the straight vessel. So straight arteriole, the capillary bed is vasa recta. It drains out the straight venule, and it goes to the arcuate vein. All right, now we're gonna go over the actual nephrons. There are two different types of nephrons. The nephrons that are in the cortex are called cortical nephrons, where the whole nephron is located within the cortex. And then you have the medullary, but this is called juxtamedullary nephron, and its nephron dips deep down into the renal medulla, so juxtamedullary nephron. All right, urine flow. So we go back to the arcuate artery. Blood flow is going to go up to the interlobular artery, to the afferent arteriole, where the renal corpuscle is going to filter out the blood. So what blood doesn't exit in the efferent arteriole will then enter into the proximal convoluted tubule. So urine is collected. It then goes down the descending limb of the loop of Henle, and then it goes up the ascending limb of the loop of Henle to the distal convoluted tubule, and then it empties its urine into the collecting ducts. And you can see that there's multiple that are draining. The collecting duct has the urine, and it goes down to the papillary duct, and this is where the renal papilla would be, which is collecting all the urine. And now we're going to go through the same thing, but now on the juxtamedullary nephron. Arcuate artery, interlobular artery, afferent arteriole, the renal corpuscle. Then you again go back to the orange, the proximal convoluted tubule. Then it goes down the descending limb of loop of Henle, deep into the medulla, the ascending limb of the loop of Henle, so ascending, it's going up, to the distal convoluted tubule, convoluted because it's twisted, and into the collecting duct where we collect our urine, to the papillary duct. And that's the nephron model.